Today's topic is applications to difference equations, and this topic is from Z transforms. And now in this video we are going to solve the difference equations using Z transforms. That is, the equation is y of k plus 2 minus 2 cos alpha into y of k plus 1 plus y of k is equal to 0, and the given conditions are y of 0 is equal to 0 and y of 1 is equal to 1. And here is the solution. In order to solve this, we have to consider certain conditions. That is, z transform of y of k is equal to, see here, z transform of y of k is equal to y of z. And next, z transform of y of k plus 1 is equal to z into y of k minus y naught. And next one, z transform of y of k plus 2 is equal to, this is z square times of y of z minus y naught minus y1 by z. Clear? Now we have to substitute all these equations and see the given equation here is, what is the given equation? Y of k plus 2 minus 2 cos alpha into y of k plus 1 plus y of k is equal to 0. So in this equation, we have to take z transforms on both sides. So here, taking z transform on both sides, so this will become z transform of, this is y of k plus 2 minus 2 cos alpha into, this is y of k plus 1 plus, again this is y of k is equal to 0. And now see here, this can be written as z transform of y of k plus 2 minus 2 cos alpha into z transform of y of, this is k plus 1 plus again z transform of, this is y of k is equal to 0. And see, we have all the values ready here. In place of y of k plus 2, I am writing this whole thing, and this will become, see here, z transform of this one is nothing but, this value is z square times of, this is y of z minus y naught minus y1 by z. And this is 2 cos alpha times of, this value is nothing but z into y of z. So this value is y of z minus y naught. And this value is again, see here, z transform of y of z is equal to capital Y of z. So this value is capital Y of z is equal to 0. And now here the conditions are, see what are the conditions? Y naught is equal to 0. So y naught is equal to 0 and y1 is equal to 1. Now I am going to substitute the values here. And now if I substitute the values, this will become, this is z square times of, this is z square times of y of z, and this value is 0 and this is 1 by z minus, this is 2 cos alpha into z times of, this is y of z, y naught is equal to 0, and next one, this is y of z is equal to 0. And if I multiply, this will be z square into, this is y of z minus z square by z. So this value is z minus, this is 2z cos alpha into y of z, and this value is y of z is equal to 0. Now if I take y of z common, so if I take this y of z common, see what remains here. So y of z is equal to, y of z is equal to, this is z square minus 2z cos alpha plus 1 minus z is equal to 0. And therefore this is y of z value is equal to z by, this value is z square minus 2z cos alpha plus 1. And see, this can be written as y of z is equal to, this is z square by z square minus 2z into cos alpha can be written as e power I alpha plus e power minus I alpha by 2, and 1 can be written as e power I alpha into e power minus alpha. So I am cancelling this 2. So after cancelling this 2, see here, So y of z by z, I'm bringing this z to this side, so it divides. That is 1 by, so this can be written as a z square minus z into e power I alpha plus e power minus I alpha plus this is e power I alpha into e power minus I alpha. And see, so this is equal to, so this can be written as y of z by z. See here, this can be written as y of z by z is equal to 1 by, this value is z square minus z times of e of I alpha plus e of minus I alpha plus e of I alpha into e of minus I alpha. See the last step here. The last step is like this. And now see, I'll multiply this one. So y of z by z, y of z by z is equal to, this is 1 by z square minus z into e power I alpha minus z into e power minus I alpha plus e power I alpha into e power minus I alpha. Therefore y of z by z is equal to, so now I can take z common from this. So if I take z common, this will be z minus e power I alpha. Now from this, what I have to take common? E power minus I alpha. So if I take minus e power minus I alpha, this will be z minus e power. This is plus I alpha. Now from this, if I take, see here, y of z by z is equal to, so if I take z minus e alpha from this, then it will become, this is z minus e alpha into what remains here, z minus e power minus alpha. Now I have to resolve into partial fractions. So y of z by z can be written as a by z minus e power I alpha plus this is b by z minus e power minus I alpha. Now I need the values of a as well as b. For getting the values of a as well as b, see here, the step here is 1 by, this is z minus I alpha into this is z minus I alpha. Here it is, if I take LCM in the denominator, this will be z minus e alpha into this is z minus e power minus alpha. If I cross multiply, this will be z minus e power minus I alpha plus b times of this is z minus e power I alpha. Now if I cancel the denominator and from the numerator 1 is equal to a times of this is z minus e power minus I alpha plus b times of this is z minus e power I alpha. I need the values of a as well as b. So for getting a value, see, for first one I have to make 0. In place of z I am substituting e power minus I alpha. Clear? So if I put e power minus I alpha, this will get cancelled and 1 is equal to, this is b times of e power minus I alpha into e power I alpha. Therefore, we got the value of b as 1 by e power minus I alpha minus e power minus I alpha. So I am clearly writing it as, if I take minus common, this will be e power I alpha minus e power minus I alpha. So this is the value of b. So after getting the value of b, see, I am going with a. So now here is the substitution. If I make this one 0, if I make this one b 0, I will be getting the value of a. So z is equal to e power plus alpha. So it is plus alpha. Therefore 1 is equal to, see here, 1 is equal to a times of, in place of z I am writing e power I alpha minus e power minus I alpha. Therefore I got the value of a as e power I alpha minus e power minus I alpha. And after getting a and b, now we have to substitute. Now we have to substitute in this equation. So here is a and here is b. So this is, see here, it's very clear that y of z by see here, y of z by z is equal to, what is our a value? So a value is ready here as 1 by e power I alpha minus e power minus I alpha divided by z minus e alpha. So this is z minus I alpha. And what is our b value here? So this is z minus e power minus I alpha, and I have to substitute the value of b here. So b value is nothing but minus 1 times of, this is minus 1 times of e power I alpha minus e power minus I alpha. Clear? So after substituting a and b values, see, y of z by z. So this is y of z by z is equal to 1 by e power I alpha minus e power minus I alpha, and this can be written as z minus e power I alpha. This is minus here. So plus into minus is minus, 1 by z minus e power I alpha. Clear? And now see here. So this can be written as y of z by z is equal to, so this if I multiply, so e power I alpha minus e power minus I alpha. So if I multiply and divide with by 2 and see what happens, and this remains same. So this is 1 by z minus I alpha minus 1 by z minus, so this is minus alpha. So this is minus I alpha. Clear? And see, if I multiply and divide, what happens this one? So y of z by z is equal to 1 by 2 times of sine hyperbolic function of e power I alpha. Clear? And this one is 1 by z minus. So e power x minus e power minus x by 2 is nothing but sine hx. And so in place of x we have I alpha. So this is z minus e power I alpha minus 1 by z minus e power minus I alpha. Clear? And the next thing here you have to remember is sine h of I alpha can be written as, so in place of sine hx we can write as minus of, so this is I times of, this is I times of sine alpha. So hyperbolic function will goes, and this will be, if I bring I outside, this is sine alpha. Now I am going to substitute this sine alpha here. So this is y of z by z. So this is y of z by z can be written as 1 by 2i into sine alpha, and this one is 1 by z minus e power I alpha by 1 minus z minus e power minus I alpha. And see, if I send this z to the numerator, then y of z is equal to 1 by, so if I multiply with I and divide with I, so this is 2i into sine alpha, and again I am sending this z to the numerator. This will be z by z minus e power I alpha minus z by z minus e power minus I alpha. So this is y of z is equal to I into I square. So this is 2i square into sine alpha, and this value is z by z minus e alpha minus, and this value is z by z minus e power minus alpha. Clear? Now taking z inverse, if I take z inverse on both sides, so taking z inverse on both sides, so if I take z inverse on both sides, this will become, see, y of z is equal to, this I square is minus 1. See here, I square is minus 1. I square value is minus 1. If I substitute and send I to the minus to the numerator, this is minus I 2 sine alpha into, this value is z by z minus e power I alpha minus z by z minus e power minus I alpha. So if I give z inverse on both sides, so this will be z inverse of this one. So this value is, see here, this is z inverse and this is also z inverse. So if I apply z inverse on both sides. And since we have from the special functions that z inverse of z by z minus a is equal to a power n. So z inverse of z by z minus a, in place of a we have e power I alpha, and in place of a we have e power minus I alpha. So I am writing this one. Therefore, z inverse. So z inverse of y of z is equal to minus I by, this is 2 into sine alpha, and in place of a we have I alpha. So this is a power n. So this is a power k here, and this is in place of a we have e power minus I alpha power k. And therefore see, this is z inverse of y of z is equal to minus I by, this is 2 sine alpha and e power I alpha k minus e power minus alpha k. And see here, this is z inverse of y of z is equal to minus I by 2 sine alpha, and this can be written as, this is cos alpha plus sine. So we have e power I theta is equal to cos theta plus I sin theta. So in place of theta, we have alpha k. That is cos alpha k plus I sin alpha k. Clear? This is minus times of, this is cos alpha k minus I sin alpha k. And therefore z inverse of y of z is equal to minus I times of, this is 2 sine alpha, this is cos alpha k plus I sin alpha k. If I multiply with minus, this is minus cos alpha k minus of minus plus I sin into alpha k. Now I can cancel this one, plus, and this is minus, and what remains here? So this is z inverse of y of z is equal to minus I by, this is 2 sine alpha, and this is, see here, if you observe properly, this is for one time and this is for one time, so both for two times, that is 2I sine alpha k. Clear? And this value is equal to minus I into I, again this is I square, 2 sine alpha k by, this is 2 sine alpha. Clear? I square is nothing but, see, since I square is equal to minus 1, if I substitute minus 1, minus 1 and minus 1 become plus, and this is 2 sine alpha k by 2 sine alpha. So if I cancel this one, we got z inverse of y of z value is equal to sine alpha k by, this value is sine alpha. So this is how we have to solve. These are the simple steps if you follow, and let me explain you for once again, so you will be getting an idea. Don't feel that it's a lengthy, so the process is also very simple here. So if you observe this one, so first of all, this is the equation given. So these are the condition. So we have to apply z transforms on both sides. If you apply z transforms on both sides and apply the conditions, and we got the value of y of z by z. So y of z by z as this, and after getting y of z by z as this one, so we have to find out the values of a as well as b, and we have to resolve into partial fractions, and we got the a value and b value, and after getting a value and b value we have to substitute here, and next we have to simplify this one, and after simplifying we have to send this z to the other side, and we have to apply z inverse on both sides, and again after using the formula of special functions a power n, and so this is a power n, and now after calculating we got the final answer of z transforms of sine of alpha k by sine alpha. This is how we have to solve, as it is very lengthy but very important. Please practice and pass it on to your friends. Definitely you can score more. Thank you so much.